I am Dr. Emimal Kanaga Pushpam, Associate Professor, Department of Mathematics, Bishop Heber College, Trichyrappalli, Tamil Nadu, India. Now I want to explain iterative method for solving nonlinear equations. In the field of science and engineering, the solution of equations of the form f of x equal to 0 occurs in many applications. If f of x is a polynomial of degree 2 or 3 or 4, exact formulae are available. But if f of x is a function like a plus b e power x plus c sin x plus d log x, the solution is not exact. We don't have formulae to get the solution of such equations. In such cases, we can use various numerical approximate methods. For this, we use the following theorem from the theory of equations. Theorem: if f of x is continuous in the interval a comma b, and if f of a and f of b are of opposite signs, then the equation f of x equal to 0 will have at least one real root between a and b. The other name for iterative method is method of successive approximation. Suppose we want to find an approximate root of the equation f of x equal to 0, that is equation 1. Now we can rewrite the given equation 1 in the form x equal to phi of x. Assume that x0 is the initial approximation to the exact root alpha of the equation 2. Now put x equal to x0 in the right hand side of equation 2. We get the first approximation x1 as x1 equal to phi of x0. Again, by putting x equal to x1 in the right hand side of x2 and continuing this process, we get the successive approximations as x2 equal to phi of x1, x3 equal to phi of x2, etc. In general, xn equal to phi of xn minus 1. The limit of the sequence of approximations x0, x1, x2, etc. xn is the exact root alpha of the given equation f of x equal to 0. Now we have noted down this point. The convergence of the sequence is not guaranteed always unless x0 is properly chosen. That's very important to choose the x0. Now we can see what's the condition for the convergence of this iteration method. It can be stated in the form of a theorem. Let f of x equal to 0 be the given equation whose actual root is alpha. The equation f of x equal to 0 can be written as x equal to phi of x. Let I be the interval containing the root x equal to alpha. Now the condition: if modulus of phi dash of x less than 1 for all x in the interval I, then the sequence of approximations x0, x1, x2, etc. xn will converge to the exact root alpha if the initial approximation x0 is chosen in the interval I. Now we can see the proof of this theorem. Since alpha is the actual root of the equation x equal to phi of x, we have alpha equal to phi of alpha. Further, according to the iteration method, x1 can be written as phi of x0, x2 is equal to phi of x1, etc. xn equal to phi of xn minus 1. Now 2 minus 1 gives xn minus alpha is equal to phi of xn minus 1 minus phi of alpha. You can take that as a equation 3. Now according to mean value theorem, phi dash of theta can be written as phi of xn minus 1 minus phi of alpha divided by xn minus 1 minus alpha, where theta lies between xn minus 1 and alpha. Therefore, phi of xn minus 1 minus phi of alpha is equal to xn minus 1 minus alpha into phi dash of theta. That is equation 4. Now, using 4 in equation 3, we get xn minus alpha is equal to xn minus 1 minus alpha into phi dash of theta. You can take that as equation 5. Now, let modulus of phi dash of x is less than or equal to k for all x in I, which contains the iterations x0, x1, x2, etc., xn and the exact root alpha. Therefore, equation 5 becomes modulus of xn minus alpha is less than or equal to modulus of xn minus 1 minus alpha into k. Similarly, we have modulus of xn minus 1 minus alpha is less than or equal to modulus of xn minus 2 minus alpha into k. At last we can write modulus of xn1 minus alpha is less than or equal to modulus of x0 minus alpha into k. Now, multiplying vertically all these inequalities and cancelling the factors, we get modulus of xn minus 1 is less than or equal to modulus of x0 minus alpha into k power n. If k is less than 1, then k power n is tending to 0 as n tending to infinity. Therefore, modulus of xn minus 1 minus xn minus alpha tending to 0 as n tending to infinity. Therefore, limit n tending to infinity xn is equal to alpha. Therefore, the sequence of approximations x0, x1, x2, etc., xn converges to the exact root alpha if modulus of phi dash of x less than or equal to k and k is less than 1. Therefore, the sufficient condition for the convergence of this iteration method is modulus of phi dash of x is less than 1 for all x belongs to I. Now we can discuss what is the order of convergence of this iterative process. Let x0, x1, x2 be the successive approximations to the exact root alpha of f of x equal to 0. Let us denote ei for the error in the root xi for I equal to 1, 2, 3, etc. Therefore, ei can be written as xi minus alpha and ei plus 1 is equal to xi plus 1 minus alpha. Then the definition for order of convergence is given by if modulus of ei plus 1 less than or equal to modulus of ei power p into k, where p greater than or equal to 1 and k is a positive constant for every I, then the power p is called the order of convergence. If p equal to 1, the convergence is said to be as linear. That is linear convergence. If p equal to 2, the convergence is quadratic convergence. In the above iteration method, we got modulus of xn minus 1 alpha is less than or equal to modulus of xn minus 1 minus alpha into k. Therefore, for this iterative method, here p equal to 1 and hence the order of convergence of this iteration method is 1 only, that is linear convergence. Now we can see a simple example. We can solve the equation e power x minus 3x equal to 0 by using iteration method. First, we have to identify the interval I where the root of the given equation lies. Okay. Now from this f of x, we have to identify two numbers such that for one value, the function value is positive, then the other must be negative. Okay, then according to the theorem, we can conclude that the root lies in between these values. That is the interval a comma b, if it is a comma b. Now we can check where the root lies. Okay, for this we are finding f of 0, that is 1, which is positive. F of 1 is e minus 3, which is negative value. Okay, one f of 0 is positive and f of 1 is negative, two opposite signs. Therefore, clearly according to the above theorem mentioned, we can conclude that there is at least one root lies between 0 and 1. Okay. Now, according to the method, we have to rewrite the given equation as or in the form x equal to phi of x. For this given equation, we can write x as 1 by 3 e power x. Now find modulus of phi dash. First, before going to use the iteration method, we have to check the condition is true or false. Okay, the condition is modulus of phi dash of x must be less than 1 for all x in the interval. Okay, the interval is, now the I is 0 and 0 comma 1. Okay, therefore we are finding phi dash of x and phi dash of 0 and phi dash of 1. Phi dash of 0 is 1 by 3, which is less than 1. Phi dash of 1 is 1 by 3e, which is also less than 1. Therefore, in the interval 0 comma 1, modulus of phi dash of x is less than 1. Therefore, we can use the iteration method for this rearrangement, that is x equal to phi of x. Now choose the initial approximation which lies between the values 0 and 1. Here we are taking that x naught as 0.6. Now substitute this x naught in the right hand side of the equation. X1, if according to the formula or according to the iteration method, x1 is equal to phi of x naught. Okay, then we know the phi of x is 1 by 3 e power x. Therefore, x1 is equal to 1 by 3 e power x naught. That is 1 by 3 e power 0.6, which gives the result as 0.60737. Similarly, we can find the successive approximation x2, x3, etc. Now x2 is what? 1 by 3 e power x1. We got the values for x1. You substitute that in that place. The result x2 is 0.61187. Similarly, we can find x3, x4, x5, etc. In the x values x12, and if you see the values of x12 and x13, we are getting the repeated values. Okay, 0.61900. Thus, therefore, we can stop the iterations here and we can conclude, or we can take this value, that is 0.61900 as the approximate root of the given equation. Okay, in a similar manner, while using this iterative method, we have to rewrite the given equation in the form x equal to phi of x